One more thing, this chapter what we are studying, right? The signals. It is fully more into theoretical part. Okay, please remember, students, here maximum things you come across is about the syntaxes. You may say now, sir, signals where it is used. You can only work practically with the signals when you are dealing with Linux internals. There is one more subject known as Linux internals where you'll actually work with the signals practically, because all signals are at the kernel level. As I said, you trying to do something and your system should not crash for you. Okay, so here moreover the more part what we are studying is into the theoretical part. Hope I'm audible. Yeah, again just one last confirmation. Either of you audible, visible? Yes, audible. Yeah, screen was sharing, right? Okay, fine. Yeah, we'll come back here now. आवाज सुन पड़ेगा। Sorry, okay. Just this is what happens when we rely on the technology directly. Sorry for the inconvenience caused. Okay, I will continue. Okay. So as we said about signal, we'll raise alarm API. I will study about signal set. Okay. What are signal set here now? Now, what happens is when multiple signals are represented by a data type, is called as signal set. Now, it is very important to note that the number of different signals available is more than the bit in an integer. So the signals which are available are more than the number of bits per integer. So all these are defined in a data type known as sig set underscore t. And to do that, we have 5 functions here. The first one is sig empty set. Okay, what does the sig empty set do is it initializes the signal set pointed by the set and pointed to all that signals are excluded. So what it does is it initializes a signal set pointed by the set, pointed to by the set, this one, that all the signals are excluded. So whichever signals are given in the signal set are excluded while its execution. There's something as sig fill set. So what does sig fill set do is it initializes the signal set so that all signals are included. So whichever signals are given in the signal set, all the signals are included for its execution, which means that a process which is running will have more than one signal for its execution. And there's something known as sig add set. Now what does sig add set do is will add a single signal to an existing set. Now the existing set has 4 or 5 signals. So for them, it adds one more single set or single signal, which is specified by the signal number. And there is something known as sig delete set. So what the sig delete set will do is it will remove a single signal from a set. So now set has more than one signal. So from that, whichever signal you want to remove is removed by the sig delete set. So right now at this point, which you are studying is only for you to understand that a process can have more than one signal also, and all those signals can be grouped in a set known as signal set. So keep on throwing all those signal set. Simple example of signal set, I'll tell you what exactly is the signal set here. You'll understand. You people have played the dart game, right? So when you go for a dart game, they give you 3 or 4 darts, which you keep on placing them, right? So what happens here is the dart game. You have 3 sets are there, 3 pieces, right? So you keep on hitting it. So whichever hits, it will be the bullseye for you, right? Same thing happens here also. This is what happens in single. So for a process, there are more than one signal, more signal, and those are grouped in a set known as signal set. And there are various system calls available which manipulate the signal set, because for a process you are giving more than one signal. So whether all signals should be executed, whether all signals should be excluded, whether some signals should be added, whether some signals should be removed. All these functions can be done by the API sig empty set, sig fill set, sig add set, and sig delete set. So this is just for your remembering purpose. Nothing more to do in this part here. Then there is something known as signal mask. Very important over there. Okay, what is a signal mask? Now, what is a signal mask? Signal mask of a process is the set of signals currently blocked from the delivery to that process. Assume that there is a process and you have executed now signal set. We know now what is a signal set. More than one signals are set to the process. So what is a signal mask? Signal mask of a process is nothing but the set of signals that are currently blocked from delivering to that process. For example, there is a process running. For that process, you have delete signal, you have kill signal, you have ignore signal, you have interrupt signal. Four signals are thrown at the same time. So when the four signals are thrown at the same time, not all four will execute at the same time. Some are being blocked because of its priority and all. Some are blocked because no resources are available. So the signals which are thrown to a process, not all are executed at the same time. Some signals are waiting or some signals are blocked, and those signals are known as, or that process is known as signal mask. Okay, so a process initially inherits a parent signal mask when it is created, but any pending signal for the parents are not passed on. That is what. Now simple example is here, signal mask. What it means is, whenever a parent creates a child process, whatever the signals are imposed on the parent are not passed to the child, are not passed to the child. Some signals are blocked at the parent level only. See, please understand this scenario. There is a parent process. Parent has already given five signals which will block the parent. But when a parent creates a child, the same signals are not imposed on the child. Same signals are not imposed on the child. So parent process, whatever the signals around parent process are not passed on to the child process. And this can be done with the help of SIG Pro Mask API. Now SIG Pro Mask API has three arguments. The first argument is the old mask, which says here now. Old mask is nothing but it's a non-null pointer that current signal mask for the process is returned through the old mask. So whatever the signals are blocked for that process are returned by the old mask for me. And the new mask is nothing but again it's a null pointer. It's a null pointer that the command argument indicates how the current signal mask is modified. Okay, how the current signal mask is modified. So it has three arguments. The last argument is nothing but the old mask which is already imposed on the process. If it is imposed, it shows. If it is not imposed, it ignores. New mask is nothing but it indicates how the current signal is modified. So if the signals are already given, if the signal should be blocked, non-blocked, all that is specified by the new mask. And what is a command? Now command has three values here. Okay, the first value of the command is sig set mask here. I've just shown here. So new mask argument defines a set of signals to be set or reset in a calling process. So the new, this is what I'm talking about. The new mask, the second argument is a pointer. See again it is in sig set underscore t only because it has n number of masks over there. So it's an argument that defines a set of signals to be set or reset in a calling process. Okay. Now there are some already signals are there which are already imposed on the process. If you want to set them or reset them, set means activate them, reset means stop them. Is all specified under new mask, and all this is taken care depending upon the command value, which is nothing but the first argument, the command value. So what is the first? There are three variations of the command value. The first one is sig underscore set mask. Now what does this command do? It overrides the calling process signal mask with the value specified in the new mask argument. That means if the first argument is sig underscore set mask, what does it do is whatever the old mask was there is overridden by the new values. For example, if a process has old mask is to terminate the process and to hang the process. This is the old signal given. Now, if the new signal which you have passed is to terminate and kill, and if this is set, so for that process, what are you doing? You're setting this new mask. It overrides the old mask with the values in the new mask. This is done only when the command value is set mask. Second one, sig underscore block. It adds the signal specified in the new mask argument to the calling process signal mask. So whatever new mask you have specified, so that will be going in the block process. Even if you're trying to pass it now, it will be preserved it and it will be blocked until and unless you call it again next time. So you can update the signals which are already specified with the new signals. You can reset and all. All this depends on the command value. That is, sig set mask will override the calling process signal mask with the value specified in the new mask argument. Something like whatever the old values are there, those are written overwritten by the new values. Sig block is nothing but the signals specified in the new mask of the calling process are masked form. And if the command value is sig underscore unblock, it removes the signal specified in the new mask argument from the calling process signal mask. Now when I say unblock, what it means is the sig old mask has some signals already given over here. For example, it has the signal to kill a process. It has a killer process. So what I'll do is I'll specify this as kill here. Again, I'll specify kill here, and I'll say it as unblock. The command as unblock. So what does the command do here? Since it is unblock, so from this list, which was kill, is removed, which is specified as this argument. So this is nothing but the values which are present here itself. Those all are removed in the new mask. And this is how your signal mask will work. First it says whether it is empty. If it is not empty, you can add it. If it is added, you can unblock it and you can remove it. So all this depends on this three values of command. Sig underscore set mask will override to the new values. Sig underscore block will add the signal, and sig underscore unblock will remove the signal. Okay. Now this is the examples here. This will give you a simple example which I have tried to address it properly. Look at this. So initially what I'm doing in the main, I'm setting a signal mask by the data type sig underscore, sorry, sig set underscore t. So initially I'll check whether the mask is empty. This is what I said here. See, sig empty. It returns 0 if it is okay and -1 of error. So first I'll check whether the mask which is defined, it has some mask or not, whether it is empty or not. If it is true, if it writes 0, then you're initializing a sig pro mask. That is for the first argument. Command 0, 0 and mask if it is -1. That means there is an error. There is no mask set. Else you have to add the signal set. See, initially you are checking whether it is empty first. If it is empty, then you will add it. What you are adding? You are adding a mask of type SIGINT. So this signal will be added to the mask, which is nothing but sig pro mask. And sig delete set will remove this signal from the given set format. Then I'll check if sig pro mask is already has some values. See, you directly can't check this because first you should check whether it is empty. If it is empty, then you need to add the values, which I'm adding it. Sig interrupt as the value in the signal mask. Then I'll call if sig pro mask sig underscore set mask, because now what I'm doing, I'm setting a mask, which means I'm overriding the old value with the new value. Sig set mask, which value you are setting? This mask value, which is a mask value, the SIGINT. You're setting it to the, sorry, you're setting it to the, you're setting it to the new value, which is nothing but -1. If this is equal to -1, it shows an error for you, or else this mask, which is SIGINT, is set to this process. Please understand this, bit confusing but easy to understand. So whenever you are setting a mask to a process, that means whenever you are hiding it, you make sure first whether it is there's some data is there to hide or not. If not, first check whether the signal mask is empty or what. If it is empty, then you need to add it. Once you add it, you have added a mask here now, SIGINT. Now initially it had no mask, nothing was added, so it is 0. Now you have added to the set SIGINT, that is signal interrupt, and you are deleting SIG So what you can do here is, once this is done, now you are calling a signal pro mask. Now signal pro mask, what it does, it blocks, this is what it is. Signal mask of process is set block from delivering to that process. So what is being blocked here now? The new value. Which is a new value? The new value specified by SIGINT. What I'm doing, I'm trying to set mask. That means whatever the previous value was there, that is replaced or updated with the new value specified by the here mask, which is is nothing but the SIGINT value. And after this system, if it is -1, it shows an error. If not, it sets a new signal mask. So a process which is running here, it had no signals to be interrupted. Then you have set a new signal which will be interrupted for that. Okay, so this is called as SIG Pro mask. Okay. No. Yes. Okay. Is this clear now? SIG Pro mask. Please remember what it does. It checks whether the interrupt signal is present to a process signal mask and adds it to the mask if it is not there. That is what. Now signal interrupt, first it checks whether it is empty. If it is empty, add it, and if it is not available, you are adding it. So initially it is not having any signal. So see here, the following example checks whether the signal interrupt signal is present in a process signal mask and adds it to the mask if it is not there. Then clears the SIGV signal from the process signal mask. So what it does here is, first it checks whether it is there. If it is not there, which is here empty. Yeah, it writes -1 on error, 0 on empty. So since it is empty, it writes 0. Fine. This will never execute. It comes to the else part because it is not empty. It has some mask. So else part, you are adding it. What interrupt you are adding? SIGIN. Now this is being added to the mask, but initially it had some values. That is SIG SEGV. Now that is to be removed from that set, which is to be done by the SIG delete set. Now it removes this element and adds this to the signal set. But this signal set should be masked also. So that can be done with a system called SIG Pro mask. SIG Pro mask, set mask. What is that? Command. Command is to set mask. The new value is nothing but SIG int. Now this value is being added to the existing signal mask. Okay. I hope this is clear. We'll stop it for the day here. Okay, students. One more thing, just a minute. We'll come back here now. One more thing, just I wanted to say is tomorrow